clFFT is a package that uses the graphics cards, the GPU, to compute Fourier transforms. It says here it works on CPU or GPU backends, and I don't really know what that means. Anyway, with the help of Jürgen Kars, Linrad today can use clFFT with OpenCL, and in this video I will show a little bit how it behaves. When clFFT is present, we have this function 6 test OpenCL, so I press 6. And the output comes in the terminal window from where Linrad was started. So I close the Linrad window, and here we can see the output. Platform 1, device 0, it's the NVIDIA Quadro K600. It's the video card of this computer. There is one more. I go back on the output. Platform 0, it says AMD Accelerated Parallel Processing, and the device is Intel Xenon CPU E5 2637 at 3.5 gigahertz. And this one says 128 gigaflops, while the NVIDIA says 188 gigaflops. That's evaluated by the routines in oclprogs.c of the Linrad package. I'm using the Blade RF. The reason is that this hardware can allow a very large range of sampling rates from, I don't remember, a couple of 100 kilohertz somewhere up to 40 megahertz. And that is complex data. So the bandwidth is from very low up to 40 megahertz. And these are the parameters at this moment. X, and I run the FM mode, that's E. And I can click on the station here.
I december 2011 publiceras en bild på Johan tillsammans med de andra som
you can see here now the total load is 9% and one thread is at 80%. And this is what you can see on the system monitor.
De har alla orangea t-shirts på sig.
At this moment I press X and P. You can see it is first FFT forward version 5. It means clFFT with OpenCL. I changed it now to number 4. That is twin radix 4 DIT with the single instruction multiple data. That's the fastest routine in the main processor. And I leave everything else the same. And then click on the same station here. And now the load is significantly lower. 54% on the worst thread and 7.7 in total. It looks like this. But if I go for a normal implementation as X, P, and for example 0, which is a straightforward implementation in C language. And then you can see it doesn't work right. There are buffer errors. I click on the station here. And there are errors, underrun errors, because we don't get the data in time. And there is one thread close to 100%. So this does not work. However, with this old and not so good implementation of the FFT, I can select to run it on parallel threads, at most 6 of them. And then you can see the worst load is 40%, but the total load is 16. I press on T, and you can see there are many threads at about 30%. The F1B with various numbers is 32%. And many cores are fairly highly loaded. So I go back on the parameters and set the I can't run parallel threads with the clFFT now. I don't know why. So I have to set this number of B threads to 1 to not have them in parallel. And go back to the clFFT. And then X, and I change the GPU parameters, that is S. And now I go for platform 0 and device 0. This is and the batch size has to be 1. Higher sizes should be better, but it doesn't work. Not yet, at least. And I go back to FM mode and try to listen. And you see, this does not work right. Now Linrad is using the embedded graphics card on the main processors. And you can see all the cores are heavily used. The total load is 45%, but the load attributed to the threads is not very high. I press T, and you can see here none of the threads reports a high workload, but the workload is attributed to Linrad anyway. That's workload on the main processors doing the GPU stuff. So this is not a good idea at all. This is the information in pros CPU info on this computer. You can see E5 2637 at 3.5 gigahertz. Processor 0. And it goes up all the way to the last one is processor 15. It means there are 2 CPUs, each one with 4 cores, and all of them have hyperthreading. And that means there are 16 CPUs reported. This is a slower computer. It has 2 cores and they are both loaded close to 100%. I am running Linrad with the Blade RF at the sampling frequency of only 1 megahertz, as you can see here. The worst loaded core is at 95%. That is the FFT1 computations. They are done in the GPU, the NVIDIA card. It's this one down here. The screen comes from this card. I don't know how to set up things properly, but this one cannot do OCL, OpenCL. So anyway, This is very close to the maximum capacity I can have from this system. And I will show the parameters X and P, and you can see FFT version 5, that is clFFT with OpenCL, and X. Then you can look at the GPU parameters, that's S, and there's only one platform. It's reported to have 92 gigaflops, while the other computer that could do 15 megahertz was reported to have 188 gigaflops. That's just a factor of 2, but the actual performance ratio is more than a factor of 15. So something is seriously wrong here. I can go back here and select just on a single thread the FFT version number 4. That's the fastest one that runs on the normal, on the main processors. And I click here. You can see the load on the processors is much lower. And the worst thread is at 43%. And both cores are loaded equally much, so there is not really any advantage of telling the system to use more threads. We only have 2 cores here. And I can try some simpler FFT implementation, let's say 3. It's twin radix for decimation in time, implemented in C.
Reda på varifrån han fick de här vapnen, var han köpte dem och vilka vapen som användes.
We have to wait for a while for the system monitor to actually report what we have, and it's very close to the same.
So Fernando Arias korrespondent.
X and P, a very simple plain C language, 0.
Med Tom Petty and the Heartbreakers på 70-talet. Bandet har släppt låtar som American Girl och I Won't Back Down.
And it's very similar. So it depends on the CPU and the cache size and other stuff, which FFT implementation is the best one, but the differences are small. But one thing is clear, using the GPU is not good at all. And I cannot interpret this in any other way than saying that clFFT seems to be using the motherboard processor and not the GPU. And it was said on the clFFT site, it can use the GPU or the main processor. And I don't know why it seems to not use the GPU. Maybe others can help here. I don't understand much of this, but I can show us a little bit more about the details I have. Let's see. We have NVIDIA detect It tells me there are 2 graphics adapters. This one does not come up as a useful device. And we have here the information about this computer. It has 2 processors, 1.86 gigahertz, and Core TM2 CPU 6300. I don't know much about that. The CPU currently runs at 600 megahertz, but it's capable of 1.86 gigahertz. And it's the same here.